Hey everyone, Mr. Fritz here. We are talking about vectors in coordinate geometry. We are putting points down and using vectors inside the coordinate plane, and we're really doing the same stuff that we've been doing with vectors. So let's take a look at another example where we're just really adding another point to the mix. I want to graph all three or plot all three of these points. A is 1, 2, 3, down 2. This is point A. Plot point B is at 2, 6, 1, 2, 3, 4, 5. This kind of goes off the grid a little bit. That's okay. Here's B. And C is -1, -4. 1, 2, 3, 4. All right, so those are my points that are just floating around in my plane, and I want to find some vectors. I want to find vector AB and the distance from A to B. So if I were to plot that, this would be my vector AB. So let's do that first. Let's go green here. So for vector AB, if I want to just find the vector, it doesn't specify if I want components or magnitude and bearing form. So I'm going to go with what's easy. I'm going to go with the component form. This is going to be given as 2 minus 3. That's my horizontal step from A to B. And then I'm going to take 6 minus -2. That is my vertical step from A to B. So that vector AB is given as -1, 8. So that part is done. Now let's find the distance or the magnitude of this vector. So the magnitude is going to equal the square root of the sum of the squares of the components. So I want the square root of 1 squared plus 8 squared, and that's going to come out to be the square root of 65, which comes out to be about 8.1. So there you have it. There's AB, vector AB. So next up, let's do vector, well, what does it say here for this one? BC. We want to find vector BC and the distance from B to C. So let's just draw that in. And I want BC emanating from B, terminating at C. Remember, the order is important. The direction does matter. So let's figure this one out. Vector BC is going to be given as -1 minus 2 and -4 minus 6. And those components come out to be, vector BC is -3 and -10. And again, you can verify this graphically. Count your step vertical or your horizontal step, count your vertical step. It should come out to be the same thing. Let's find the distance or the size or the magnitude or the length, whatever you want to call it, of vector BC. So that's the square root of -3 squared plus -10 squared. And when I add all this up together, I get the square root of 109, which is approximately 10.4. So there you go. Here's another problem that I'd like you to try. A little bit trickier because we're dealing with midpoints. M is the midpoint between A and B, and you know that because it tells me that the distance from A to M is congruent with the distance from M to B. So I'm guessing that you can figure out what that coordinate of M is, but if you're not sure, I just want to remind you that the midpoint formula is going to be given by x sub A plus x sub B over 2, comma, y sub A plus y sub B over 2. Your midpoint is basically the average of your x's and the average of your y's. So hopefully it makes some sense. You might need to use this, but give all three of these a shot. They're a little bit tricky. And resume the video when you're ready to check out the answer. All right, so here is my answer for this you try. Look through the work. Hopefully it makes some sense, and hopefully you got it right. Here's another example. We're just doing more geometry in the coordinate plane with vectors. So I want to find what point B is if C is the center of a circle with diameter AB. So let's just plot that center of the circle. C is 1, 4, 1, 2, 3, 4. And A is at 3, 1, 2, 3, -2. So this is C and this is A. So I'm actually going to draw a circle in here. And this kind of like goes way through the prompt. That's okay though. We just want to visualize. So let's visualize this diameter like this. And that means that way up here, way off of my paper, or way off of the grid here is point B. And that's what I want to figure. I want to find what that point B is. So there's a couple of different ways you can think about it. One thing that I'd say is that since C is the center of the circle, C is the midpoint of AB. So that's pretty important. Really, this is just a midpoint problem, but it's just kind of disguising it with circles. So that means that C is 1, 4 is the midpoint of x sub b plus whatever my x value for a is 3 over 2, comma, y sub b plus whatever my y value for a is, which is -2, over 2. So basically the average of my a and b gives me the midpoint C. So I can break this down into just the x's and the y's. So let's do this. Let's make the x's all red. So that means that 1, the x value of my midpoint is going to equal x sub b plus 3 over 2, which means that 2 is going to equal x sub b plus 3. That's if I multiply both sides by 2. So the x value of my coordinate b is going to equal -1. And let's talk about the y's. Here's my y value, here's my y value. 4 is going to equal y sub b minus 2 over 2. Multiply by 2 again, I get 8 equals y sub b minus 2. And y sub b is going to equal 10. So the coordinate of b is -1, 10. And again, you could have visualized this. What you could do is you could count the horizontal step over from A to C and then up. And you could have just added, or I guess subtracted, kept moving in the same direction, the same number of points, and you would have gotten to B kind of a visual way. It really doesn't matter how you slice it, but we get there no matter what. All right, so I'd like you to try a problem just like it. In fact, it's so similar, it's the same type of style, but just different points. So pause the video, see if you can't find the next coordinate B given the center of a circle and the diameter is AB. Resume the video when you're ready to check out the answer. All right, so here is my answer here. Vector B, or rather point B, is at -2, -9. And I took the approach of just kind of counting my steps here. I found that to be the easiest case. All right, why don't we take a break here, and in the next video we're going to do some stuff with parallelograms and some solving equations in component form. So rewatch any of this stuff if you need to, or review any of these you try problems, and we'll see you in the next video.